Hello YouTube, this here is a hood. It's got a fire alarm on it, and we're going to shut the units off with this fire safety switch. In case if there's a fire in here, they'll set the alarm off, and then it's going to shut this unit down. So this is, you know, the beginning of the video. I was going to go ahead and let you know we've got two wires going to our smoke alarm system. Our smoke alarm system is going to have a normally closed circuit to this normally closed circuit. And when this opens, the normally closed circuit, in case of a fire, the unit's going to shut off. So I want you guys to see what we got going on here. I'll just go ahead and show you. Alright, so we got common and normally closed. Common's red, brown's normally closed, so we got common and brown right here. So red and brown, and then we got two wires right here going to it. This system is not specific. We're not going to put any of these connectors inside because it's all going to be low voltage, 24 volts running off of this system. And then we can't put the wires in the box just because the electrical inspection, the way this is set up, we can't do it. Because inside of this box there's 110 volts for a different connection. And this is a low voltage circuit, so they want to keep it separated. And that's basically this. And this is just your standard stainless steel hood that it sprays water out of these nozzles here, or the solution, fire repellent, retardant stuff. Alright, and we're going to get to the next part here shortly. Okay YouTube, I'm going to go ahead and show you what's going on right here. This is two different shielded wires. It'll work, but I would have preferred one shielded wire and one thermostat wire. It's 18/8. That way if we have any trouble in the future, we can go back and resolve it. But with this setup, it's impossible to do it unless you replace a wire. If a wire inside the walls breaks, somebody cuts a wire in the wall or anything like that. So what we're going to do is we're going to mount this module. It's not a thermostat. This module is for an AAON unit. Okay, I'm going to show you here. This is a module. Here's the front faceplate of the module. Here's the back faceplate of the module. It does not turn the temperature up and down. It is a monitor module, so they can monitor how the equipment's operating. So we're mounting this to this, and it's really sensitive to radio wave frequencies on the thermostat wires, so they use shielded internal wire with ground to protect it from any kind of a problem. So this will work, but it would be preferred to have an 18/8 and a shielded wire. So 18/8 and a shielded wire is better. Also, we don't know which wire is what on the roof, so I put a wire nut between all the wires on this side, and now we get to go on the roof and check and see which one of the wires are have continuity between them. So this wire is going to be an open circuit wire. None of the wires are going to be touching. So, and this wire, all the wires are going to be connected directly to each other, so we can determine which ones are the wires that go where. Because these wires are the same colors and these wires are the same colors. So we have to distinguish the difference between the two. And I just wanted you to see that. And also I'm going to show you the other smoke alarm parts. First, I'm going to go over this. You can see this page here. It's a simple page. And I'm going to zoom in here. And this here is the color code for this equipment on the roof right now. And I'm not going to say where, but I'm just saying this is the color code. You got red, blue, black, and brown. Alright, you got positive auxiliary, negative auxiliary. This equipment's going to be running off of DC power. And then you got accessory, which is a signal, and then accessory, which is a signal. These are not direct connection power. These are signaled by the control modules inside on the walls for the smoke alarm. So we're going to have red, blue, black, and brown. Red and blue is for the power, red's for the positive, blue is for the negative. Black is going to be accessory negative, and then accessory positive is going to be brown. Let's go over here and look at it. So, this is our module that's controlling everything. This module flashes when the alarm is set off. Also, it's wired up exactly like I told you before. Red, blue, black, and brown. So I want you guys to see exactly how this is wired up. The red, blue, black, and brown. And then underneath the screws on the PCB board, you can see auxiliary and then accessory. And it's all wired up by specification. So, and these are my specifications for this equipment. And we're going to get to the next part here shortly. I do apologize. This is, an ongoing process. It's going to take a while to get done. So I appreciate it, and we're going to show you the fire alarm here shortly. That's going to be shutting all the equipment down at the same time. And then we're going to show you how to wire up the fire alarm into the outdoor unit, which is a AAON 10-ton straight air conditioning with electric heat, and it's really nice for restaurants. If you're trying to balance your building, this unit is the unit that you want to balance with. So we'll be back here shortly with the next part. Okay, YouTube, the next step is we're going to check the resistor on here. First, we check the temperature, and then we go to, it's 81.7, 81.6, so it should be in between 8,893 and 9,302. So now we're going to check by ohms. We're going to switch it over to ohms. I'll show you the temperature right there, 81 degrees. And then we went to our chart that says 80 to 82. Now we got to check the resistance of the temperature sensor on it. And it says right here we need to check the resistance between the temperature sensor between ground and the plus on the test leads. So here is ground and auxiliary, which is plus. Alright, the plus is on the left and auxiliary out is not the plus. So if you look here, we've got 8,085 or so. So that's really close to 82 degrees. That couldn't be more accurate if you ask me. That's pretty close, so that's pretty good. And I just wanted you guys to see, you should always check your resistance on your temperature sensors by the chart when it recommends to check it in the instruction manuals. So the instruction manual that you're supposed to read the whole thing. After you read it, you do what it says, and then you don't have any trouble. So if I was having trouble with that thing, now would be the time to change it up. But as of now, it's doing good, so we're going to install it on the wall. This is the temperature control switch for the AAON unit. Also, I was going to go ahead and show you red, bare, and black is going to be the colors we're using for this. Hello YouTube, this is the next part of this job here. Right now we've got all this circuitry we're going to be working with here. Everything's got to be tightened back down individually. I'm not going to bore you with that. But like I said, every single circuit's going to be tightened down and torqued down. They do it from the factory. If you can get closer in, you can see how it's been done. That, by the way, there's no power on this. And then we got to connect our indoor module to here, and then we got to break this wire here for the fire alarm system. We got to install a new transformer here with a breaker on it for the fire alarm system, and we got to connect our ductwork modules wires back together here. So you can see what we got going on. We got these two red wires go to the indoor module that displays what the unit's doing. This is going straight to the smoke detector. We took a picture of it before we took it off. I think it goes here somewhere. I'm not exactly sure which one, but I'm really sure it goes right there. And you know, right here is our three-phase breakers. All the equipment's three-phase. The power going into it is 208 volts, and we can't check for the phase correct direction right now because there's no power on the equipment, but we can wire everything up and get it ready to start up. So I wanted you guys to see what type of work I normally do here. So this is the type of stuff that I do whenever I'm not sitting at home making YouTube videos. But I do this once or twice a year, so they like my work. Alright, I'm going to let you go and show you when I get everything back together. Hey YouTube, I was going to show you a quick part of the wire stripping. You can see I stripped it back to a little bit, and then I got this fiberglass strand, and what I'll do is I'll wrap it around my finger and then pull on it. Okay? And when I pull on it, I'm able to strip it back, get the coating off easily, and then I just trim off the part that may have been scored. So that's basically what I do with it. Okay, what we've got going on, you can see this connector I'm pointing at. This is the connector that is the negative circuit for our module. Here's the positive circuit for the module. Now this is alternating current here, but since it's mandatory for the negative circuit to be neutral leg, it's bonded right here from this bar to that one right there. So I always, you know, whenever I'm doing the negative circuit, I put it on the circuit that's bonded, and then this wire is going to go into this S1, S2, I believe. I had to double check the photograph that we made. And then we're going to, you know, we got this wire here. It's going to go up over here into this control module. That's the other three wires that go to the control module. This is the bear, this is the R, and then this is T. And next, we're going to cut this wire in half, and then we're also going, this is our new transformer we put in. So we have put this new transformer in, and we wired it up right here. You can see this connector here and this connector here. This is 208 volts right here, single phase. So we got 208 volt single phase setup right there, and then, you know, this is the main power coming in. This is all the electric heaters, all of them. Every one of the fuses go for the electric heaters. There is 6 total heater contactors in this unit, and they're 50 amp contactors under full load amps. You can see it right there. FLA is full load amps at 50 amps. So you can see you can see my finger, and here's the wire, and this is there's 2 going in here, 2 going in there, and then 2 going in right there. So that works pretty well, and it looks like we're pulling some more wire up right now. So this is our wall temperature sensor wire, and we're going to feed it in through there with the rest of the stuff. And then we've got this other thermostat wire here. We're running that to our smoke detector, which is going to be powered by this transformer right here. So, you know, then we're going to, you know, just use this transformer by itself and power it up, and then that's going to be good to go. They're changing these units every time we put one in. They're changing them up, so it's not like, you know, they're always exactly the same. But I think we've got the temperature sensor is going to be the ground here, and then A17 right there. If I go over here and look, A17 is empty, and then this wire is going to be added additional. We're going to add additional wire to ground right there. So here's our electrical diagram. Tons of stuff on there for you to read if you like it. You know. But this is our diagram for our fan control system and the module system too. So, you know, we're looking at this is our main deal right here. This is the one that does everything right here. It turns everything on and off, and when we turn the power right here on this red wire, it shuts down. So, you know, this is our red wire that shuts down. It's on the very top left-hand module. And this is where we're going to cut for our smoke alarm, emergency shutdown. We're just going to make a simple loop for it to go through, and then, you know, it's going to turn everything off. So this is Phil 20 with you guys, and I'll be back whenever I get this wired up the rest of the way. Okay, YouTube, we've got all of our wires tied up and cleaned up. It runs all the way across and up, and then all the way through here and up, and then back over to our transformer, and then back over to cut off all of our circuits here. That runs the control module inside. This runs the temperature sensor inside here, you know, and we had to rewire this back into place. This right here runs the duct air temperature sensor. It's not too bad to start this up. Before we start, we're going to check every single screw on it and make sure they're all tight. After we get done checking that, we're going to check the polarity in the phase, make sure it's in the correct phase, and then we're going to run it. We're going to have heating and air conditioning. All my paperwork is safely stowed away. All my contactors, nothing in between it, no metal getting in the way. Everything's good to go. I want you guys at YouTube to see what I normally do, and I want you guys to comment on it. Tell me what you think about what this is. Let me know what you want to see next. You can see some of this cool stuff we can build. You know, we made a whole circuit for a whole nother thing. I'm not done yet. I've got one more part to show you. It's going to be the smoke detector. I'll show you that here next. So stay tuned. Okay, YouTube. I got about 11 minutes left. I hope I can get it done in a quick enough amount of time. What a piece of shit. I just bought these and now they're all fouled up from thermostat wire. Can you believe that? Thermostat wire. IV. Look at that. They're junk. I just cut the thermostat wire. I got these brand new today. These wires go to the unit. There's only 4 wires I'm going to use from the unit, so I'm just going to trim off what extra wires I don't need. And then if I ever need extra, it's here. So I always use red and blue as my common. It varies from technician to technician. Red and blue is common in power. This is from the transformer on the roof. This is from the transformer on the roof. This is going to the control module on the roof. So we're going to have white as common. on auxiliary A. And this goes to the hood with the emergency shutoff right here. And that right there. And I believe this wire right here, and this wire right here is going to be the module on the wall outside, I mean inside, where the 4 wires tie in. So we got black, brown, and then blue and red on that. And just in case, I'm gonna wrap these wires up. So, blue and red is the power wires to the device. By the way, this is 36 volts DC power. And it's going to be under 19 and 20 here. Auxiliary power out positive is going to be red. This is number 19. Number 20 is auxiliary out negative. It's going to be blue. Do accessory negative, which is black. It's going to be on ACC negative. And then ACC positive is going to be brown. And that goes to the module on the wall with the key shut off. And then we're going to wire nut these 2 green wires together, and that'll complete the circuit. So the unit will run. I'll be right back. Hey there, boo. What are you doing? Huh? Nothing. Having a little problem, didn't you? Doing all right? Okay, I got a wire nut on it, and basically we're all done here. There's not a whole lot I can do right now. There's no electricity on the building that is going to be serviceable at the moment. So I'm going to close the device. Get everything down, and then I'm going to show you the control module, the last part of it. I want to go over this real quick, YouTube. This is a alternating current module, but this has a polarity that requires the 24 volt neutral. Okay, so there's two holes here, and then inside of here you got a negative and then a positive. The negative is going to go to the chassis, and the positive is going to go to the voltage. So I'm trying to show you, it's hard to see. The negative right here is going to the chassis, and the positive is going to the power from the transformer on a 24 volt circuit. So this is a polarity device, and it is important because it's got a certain type of communication with the system. Apologize for the lighting, it is what it is. But this left side is the negative, which I have as a black wire here, and the right side is positive. And then I just plug it up and screw it in. And I want to thank you again for watching the work here on YouTube land. And if you got any videos you want me to do, let me know. I appreciate it. This is Philip 20 with solar power, electricity, and electronics, and I'll holler at y'all later.